Hello everyone, happy to see you here. Welcome back to my channel, Hi Mathematics. Today we have a very interesting equation, 2 to the power a plus 2 to the power a equal to 40. We need to solve this question for a, so if you have your answer, your solution, you can also write it in the comments below and then we will check our answers. Okay, so first of all, on the left side we have 2 to the power a and plus 2 to the power a, so two same expression. So as a result, we can write it as 2 times 2 to the power a. Okay, without any problems, 2 times 2 to the power a equal to 40. And a lot of students might be asking, how can we write it like that? Here's my quick explanation. For example, 2 to the power a is our x, yeah? And we have the same x. We have x plus x. And when we add x plus x, when we add two same expressions, as a result, we have 2x. And as a result, right here, we have 2 times 2 to the power a. So I hope you understand this first step. Secondly, let's divide both sides by these two. Then we can easily split it by variables on the left side and constant on the right side. So let's do it. So let's divide both sides by 2. What can we get from here? We will have 2 to the power a equal to 20. Okay, 2 to the power a equal to 20. So I really hope you understand this first step. So what we're going to do next? Of course, we need to find our a. This is not a basic equation in terms of variables. This is our exponential. This is our equation in terms of power. So we need to apply log on both sides. Yeah, let's do it. So every time you have this power right here. So every time apply log, and without any problems, you can easily find this a. So log 2 to the power a, so log on the left side equal to log on the right side. Okay, log on the right side. Right now, you need to know a really important property. So whenever we have expression like log, for example, base of a, right here we have b, and right here we have power, yeah? So this c we can write in front of it. So as a result, we can write c log b base of a. So I hope you understand it. Okay, this is basic. This is like maybe the most popular algebra property, and that's why people apply log, just to write this a in front of this log. As a result, we have a log 2 equal to log 20. And our final step, we need to divide, so we need to find our a without any logs. So we need to divide both sides by this log 2 right here, okay? This log 2. And when we divide it, we have only our a. But I want to start right here on the left side, because I want to simplify this expression. So we have a equal to log 20. We have log 20 over log 2, okay, over log 2. And right now a lot of students might be saying, okay, this is our final answer, but this 20 can be written as 4 times 5, so let's do it. So as a result, we have 4 times 5, we can write it like that, all over log 2. Secondly, there are a lot of ways how can we simplify it, to be honest. Yeah, so this is my way. How can we simplify it? Of course, you can write it in your own way, but let's see how can we simplify it according to my steps. So log 4 times 5. When we have a log of a product, so when we have like a quick right here, we have quick rule. Yeah, when we have log a times b, we can write it as a sum. So log of a product is a sum of two logs. Okay, it works only with multiplication and division, and then we can write it in terms of like addition and subtraction. Yeah, so we have log a minus plus log b. Yeah, you can write it like that. Log a plus log b. So multiplication goes to addition and division goes to subtraction, but we don't have exactly that case. So equal to, right here we can write it as I said before. So we have log 4 plus log 5 plus log 5 all over log 2. And right now we can divide it by parts. So we can divide this log 4 by log 2 and this log 5 by log 2. As a common denominator, we can easily divide it. So we have log 4 over log 2 plus log 5 over log 2. And a lot of students might be thinking right here at this place, so on the right side, we can't simplify this. This is 5, this is our odd number, this is 2, so we can't express as a power. But right here, this 4 can be written as 2 square, yeah? So we can write it as log 2 to the power 2 over log 2 and plus log 5 over log 2. And right here, these two will come down right here at this place, and as a result we have 2 log 2 over log 2, yeah, over log 2, and plus log 5 over log 2, log 5 over log 2, okay, over log 2. And right now this log 2 can be easily cancelled. This is not equal to 0, so our final answer 2 plus log 5 over log over log 2. This is our final answer to this question, and I find the approximately value to this, so a approximately equal, if you're interested in this approximately value, so a approximately equal to 4.3032. Right now, in the next step, I want to check this root real quick, because it's really important. We can easily do this, okay? So our second step is to prove, is to check this root. So we have prove. And what do we have right here? We have 2 to the power a. This is our question from the beginning. So 2 to the power a plus 2 to the power a equal to 40. Let's check this this root right here. First of all, this expression can be written in a different way. I want this of course this is our answer, but I suggest you to choose another variant. How can you solve it? How can you prove it? These two we leave like that, but this expression right here we can write as log 5 base of 2. For easier calculation, we can easily do that. This is the same expression. This one and this one are the same expression. So right now, let's plug in this expression right here. Instead of this a, let's do this. Let's see what will happen. So we have 2 to the power a equal to this expression. So 2 to the power, so we have 2 plus log 5 base of 2, yeah? And we have the same expression, so plus 2 to the power the same a, so we have 2 plus log 5 base of 2 and equal to 40. Okay, so I hope you understand it. Right now we can easily split it. We can easily write it as 2 to the power 2 times 2 to the power this power. Okay, according to a basic power rule. So as a result, we have 2 to the power 2 times 2 to the power log 2 base of 2. Right here we have 5 plus 2 to the power 2, the same thing, like symmetrical thing, times 2 to the power log 5 base of 2 and equal to 40. And right now a lot of students might be thinking, this is complicated thing, we have a log in a power, but there's very interesting property. So whenever you have this type of expression, I want to underline it with this line right here. So whenever you have this type of expression, this is equal to, right here, this is equal to 1. So we can easily, in our head, we can easily cancel this thing. We can easily cancel this expression, and as a result, we end up with the 2 square 4 times. Right here we have only 5. 4 times 5 plus 4 times 5 equal to 40, and everything is great because we have 20 plus 20 plus 20 equal to 40. So our root is absolutely correct in this case. So I really hope you understand it. I really hope you understand our proof and why this root is great for us. Of course, you can use both variations, this one or this one, but I suggest you to use this one. This is goes in a very simple way. Okay. And the third step right here, I want to show you how can we find a complex root. This is up to you. Maybe you're interested in this or not interested in this. I'm going to show you how can we think a little bit about complex root. So our question, 2 to the power a plus 2 to the power a equal to 40. Okay, and from here, as I said before, we get that 2 to the power a equal to 20. Yeah, 2 to the power a equal to 20. And right now, let's try to express our both sides. So our 2 to the power a and our 20, let's express it in terms of complex numbers. Okay, first of all, right here, I'm gonna start with the 2 to the power a. How can we express this? We can express this as e to the power natural log of 2 to the power a, or this a can be written right here. So we have e to the power a natural log 2. This is how can we express 2 to the power a. So I hope you understand it. And second step, let's think a little bit how can we express this 20. We know that right here maybe we can get a complex root. So right now this 20 can be written in terms of identity, can be written as 20 times e to the power I times 2k pi, and of course we're talking about k from the set of integers. And right now let's write an equation with both sides. So this one, instead of 2 to the a, let's use this expression. So I'm gonna split this part, and I'm gonna start with 2 to the a. 2 to the power a equal to e to the power a natural log 2 on the left side, and on the right side we have this one, 20 times e to the power I 2k pi. So 20 times e to the power I times 2k pi. And right now let's find from here what we find. We can find real quick, we can find our a. First of all, let's apply natural log on both sides. So as a result, we have natural log of e to the power a natural log 2 equal to natural log of this one. So 20 times e to the power I times 2k pi. Of course, k that from integers. And right now, let's simplify this real quick. But I'm gonna continue right here, okay? So at this place. So I hope you understand it. So from here, I'm gonna continue right here at this on this left place. Right now, what can we do from here? Natural log a equal to 1. And this a times natural log 2 we can write in front of it. So as a result, we have only a times natural log 2 on the left side. On the right side, we can split it in terms of addition. As I said before, when we have multiplication, we can split it in terms of like sum of two logs. So we have natural log of 20 plus natural log of e to the power I 2k pi. Yeah. What can we get from here? So we have the same beginning, a times natural log 2 equal to natural log 20 plus, from here, as I said before, natural log e equal to 1, and we have only I times 2k pi. So plus I 2k pi. And the final thing, let's divide both sides by this natural log 2. So our final answer, a equal to, we can easily split this natural log 20 as natural log 4 plus natural log 5, and natural log 4 we can write as 2 natural log 2 in that way, plus natural log 5, yeah, natural log 5, plus this imaginary unit, I 2k pi, and we divide all of this by natural log 2, And this is our, I would say like this is our second root, this is our complex. This is our complex root right here, yeah, and right here we can easily see it. This is our complex. This is my thought about this complex root. Of course, write your thoughts, write your response in the comments below. Let's see, and what do you think about this part? So we can get from here our complex root. Right now, once more, here's our answer. Where can you get it? Yeah, you can easily see it right here. This one or this one we can prove according to this root, because it's really great to see this property, and in a few seconds you can easily solve it. And this is our approximately answer to this question. So I really hope you understand my solution. I really hope you enjoy it. So if you do, you can easily leave your response in the comments below. It's really interesting to see it, and it's really interesting to exchange information. So a equal to 2 plus log 5 base of 2, or another variation, this one. So we can easily write it in terms of this variation. So thank you everyone for your time. Here's once more we can see a solution to this question. I really hope you understand it. Write your thoughts, write your question. Maybe there are a lot of students here interested in this type of question. So write your response. Everyone try to help you, and of course I really hope this video is helpful in any way, and I hope you learn something new. Yeah, maybe property, maybe you learn a lot, maybe not a lot. It depends on you, and of course I really hope you enjoy it. So wish you all the best in your life, take care of yourself, and have a great day. See you in the next videos.